Hi, my name is Danilo and I'm Technical Evangelist in Amazon Web Services. Here I'd like to introduce you to the new Amazon Elastic File System service. The goal of this session is to introduce you to the service, and we will cover both beginner topics and more advanced concepts in the second part of the presentation. The agenda today is to provide an overview of EFS, introduce you to the technical concepts for EFS, see how you can create and easily use a file system, discuss the security mechanisms that are in place to protect your file system with EFS, and explore the regional availability and the durability model. Let's start with an overview of Amazon EFS. AWS already has a quite broad storage portfolio. So we have Amazon S3, that is an object storage, where data is presented as object collected in buckets, and data can be accessed via HTTP APIs, HTTPS, of course, if you want to be more secure, over the internet. Amazon Elastic Block Store, or EBS, is a block storage. It is presented as disk volume to EC2 instances and is the lowest latency storage that you can use from an EC2 instance. Amazon Glacier is an archival storage. Data is presented as archives collected in vaults. It's the lowest cost storage and is perfect for infrequent data access. And you access data via APIs over the internet. Amazon Elastic File System is a file storage analogous to a network-attached storage. Data is presented to the EC2 instances as a file system. It has a shared low latency across multiple EC2 instances. What is Amazon EFS? It's a fully managed file system for EC2 instances. Provides standard file system semantics, and it works with normal default operating system APIs. It's shareable across thousands of EC2 instances, and it can elastically grow to petabyte scale. It's based on SSD devices to provide you the performance that you need, and it can deliver the right performance for a quite broad variety of workloads. It's highly available and durable, and it's based on an NFS v4 interface. EFS is designed for a broad range of use cases. For example, for content repositories as those for content management systems, where you have to share content across multiple instances to scale. For development environments, where sometimes we see that there is the requirement to have a shared folder. For home directories, of course, and for those big data environments where the data analytics platform is not suitable for a distributed file system like HDFS with Hadoop. Operating a shared file storage today is quite complex. This is what our customers are telling us. And it is complex for the IT administrator because you have to estimate the demand, procure the hardware. You have also to think about the physical space, because scaling a storage device means that you may need to add a new rack just aside the previous rack, and you have to plan for this physical space to be available. And then you have to set up and maintain the hardware, and especially the network, because networking for a storage, a network attached storage, is really complex to maintain and to keep with the right performance. And you have to manage the access and the security to the platform. But also for the application owner and the developers in the application, this is complex because they are the one to provide the demand forecast, the business case to the IT administrator. And if there are lead times because the upgrade of the use of the storage is not yet possible, this puts them into the situation to create extra coordination, to not be independent in their own schedule. And so at the end, this is limiting their own flexibility and the agility of the development team. And also the business owners, they are the one that they have to do a upfront huge capital investment to acquire the storage platform. Often they have to overbuy because over provisioning is always better than under provisioning when you are in production. and they have to stay on top of all the normal life cycle of a storage platform with constant upgrades and refresh. And this is diverting their focus from their business mission to IT management, limiting their own agility. So with the Elastic File System, we are trying to change this game. These are the three main concepts behind EFS. So EFS is designed to be simple, it is also designed to be elastic, and it's designed to be scalable. Let's see how we implemented these three principles inside EFS. So EFS is simple because it's fully managed. There is no hardware, no network, no file layer to be managed, and you can create a scalable file system in seconds. The integration with your existing tools and apps is seamless because we provide a standard NFS v4 interface that is widespread, open, and adopted in a broad landscape of platforms. And we have a standard file system semantics, so it integrates easily also with the operating system and with the operating system file system APIs. And we have a very simple pricing that makes forecasting very, very, very simple. EFS is also elastic because the file system can grow and shrink automatically as you add and remove file. At the beginning you have an empty file system. If you add file, the file system will grow. If you remove files, the file system will automatically shrink. So you have no need to think of storage provisioning, of the capacity that you need, or of performance tuning. You only pay for the storage space that you use with no minimum fee. EFS is scalable because it can grow from 0 to petabyte scale. And the throughput of the file system and the number of I/O operations per second that the file system can sustain scale automatically as your file system grows. So the latency of the file system is consistently low regardless of the size of the file system. And it can support thousands of concurrent NFS connections. Why does this matter to the people that we just mentioned? Well, it matters for the IT administrator because it eliminates the need to maintain and manage the file system storage, including the physical equipment at scale. It also matters to the application owners and the development team because they can easily move their existing code and application that they use today, maybe in a on-premise infrastructure if they use an NFS server. And so moving to the AWS cloud is even easier than before. And even if they have to develop a new cloud native application, the use of a shared file system storage can make things easier to do. And it also can matter to your business because you have a predictable pricing, you can avoid any upfront investment, you can test and experiment much quickly, so you can increase your agility, and you can spend less time as a business owner thinking about the management of the storage subsystem, and you have more time on focusing on your business. So we think both enterprise and startups can benefit here because enterprise can migrate their application easy, and startup, they can build their own prototype using a shared file system in an easier way, and but still with a scalable infrastructure. So now let's dive into the file system. Those are some key concepts that are probably already known to AWS users, but are very important to understand how Amazon Elastic File System works. The region, the availability zone, and the Amazon Virtual Private Cloud. So the region is the geographic area where the AWS services are available. The customers can choose the regions for their own resources. Usually you choose region to be either close to your customer or for compliance reasons. And we have 11 regions worldwide. In Europe, we have 2 regions, one in Ireland and one in Frankfurt. The availability zone is part of a region because a region is not a single facility. A region has multiple facilities, and we aggregate those facilities into availability zones. Those availability zones, there are one or more facilities, are linked together with a low latency links, so that when you launch your infrastructure, your EC2 instances, you can choose in which availability zone to deploy the instance. The virtual private cloud is a logically isolated section of the AWS cloud where you can define your own virtual network. When launching instances or other resources, you can choose to deploy them into a VPC. Actually, all new customers have a default VPC, so they don't need to create one, but if you create one, you can really define your own networking. So what is a file system for EFS? It's the primary resource, it's where you store files, directories, and you can create an unlimited number of file systems in an AWS account. To access a file system from an instance, you just have to mount the file system. So you need an NFS v4 client that is, for example, standard on Linux distributions. And then you have to use the standard mount syntax. So for example, on Linux, you use mount. You have to specify the type of the file system, NFS4. Then you need the file system DNS name, and then the local directory where you want to present the mount point. So how you get the file system DNS name with EFS? You have to create a mount target. So to access a file system within a VPC, you create a mount target, and you can create more than one mount target in each availability zone where your VPC is present. Each mount target has an IP address and a DNS name that you can use in your mount command. So how does this all fit together? So the customer file system is presented through one or more mount points in a VPC, and within this VPC you can use this mount point, the DNS name or the IP address that is provided, to mount using an NFS client the file system in one or more EC2 instances. There are three ways to set up and manage an Elastic file system. You can use the web-based management console, you can use one of our command line interface tools, or you can use our software development kits. We have SDKs for the most used development languages. With each of them, you can do the following task. These are the management tasks that you have with EFS. They are not a lot because EFS is designed to be simple, as we saw. So you can create a file system, you can create and manage the mount targets for a file system, you can tag a file system, you can delete a file system, and you can view the details of the usage of the configuration of the file system in your AWS account. It's really simple because you don't need to think about tuning, scaling the file system. Everything is managed by the platform itself. To set up and mount a file system, it takes less than a minute. You have to create a file system. You have to create the mount target for each availability zone in which you want to access the file system from your VPC. You have to enable the NFS client in your instances, and then you have to run the mount command. Let's see something from the web console to make it even clearer than that. So this is the standard web page that you get from the management console if you don't have any Elastic file system. You click on the Create File System button, and then you have to specify the VPC you want to use your Elastic file system in, and then you can create the mount targets for the different availability zones, the different subnet in your VPC. As you can see, each mount target has a security group. We will see that later, what that means when we will talk about security. You can add tags, and we recommend to add at the minimum the name tag for your file system, and you can add more tags that will make management of the file system easier if you have a lot of them. Then you can review your configuration and click on the Create File System. Then you will see your file system created. As you see in this screenshot, this file system is new, so it has 0 GB inside. You can see the mount points, and you have two links, the DNS names and EC2 mount instruction that you can use to get useful information on how to mount this file system. So if you click on the instruction, you see a few instructions on how to enable the NFS client on a Linux EC2 instance, depending on the Linux flavor. Then you create a new directory that will be the mount point of your file system. And then you can use the mount command. This mount command has a quite cumbersome syntax. If you see, there is the curl command within, and we will explain in a few moments that this is the right syntax to use because it allows you to run the same command across different availability zones. In fact, if you create more mount target for a single file system in different availability zones, those are the DNS names that you get. As you see, the only part that is changing is at the beginning when you have the availability zone of the file system. So the syntax that we had in the previous slide that you can see also here in the bottom of this page is extracting the availability zone from the instance metadata that is available locally to the instance via this HTTP request on this fixed IP address. So it's automatically replacing the availability zone at the beginning, and then you have the file system ID and the standard URL. In this way, if you use this mount command within your instances, you can easily create, for example, an Amazon machine image that can be reused in different availability zones, because in each availability zone, this command will dynamically replace the first part with the right string to use. How can you manage the security of your file system? Actually, there are three different levels of security that you can manage. You can control the network traffic, so the network access to and from the file system using the VPC security groups or the network access control list. You can control file and directory access using standard OS directory and file level permissions. And you can control management access, administrative access, so API access at the end to the Elastic File System platform using AWS Identity and Access Management Platform, IAM. So only the EC2 instance within the VPC you specify can access your EFS file system. And within a VPC, you can use the security group to specify which instances are allowed or not to reach the mount target. At file system level, you really use standard file and directory permissions. So this is really standard and normal. I don't think we need to dive deeper on this. And EFS is also integrated with the identity and access management of AWS. So you can create users, groups, and roles and give them access to the EFS service. EFS supports policies that can specify both action level and resource level permission. When you create a policy, you can give access to an action that corresponds roughly to what we saw in the management. So create a file system, delete a file system, create or manage a mount target, and resource. So you can specify only they can work on any file system or on one or more file systems. So with EFS, you can specify both and create really fine-grained policy that allow you to manage your file system or not within the AWS platform. You can, for example, create a role for someone that can create a new file system, any file system, and you can create another role for people that can delete only a specific number of file systems. So let's look which is the regional availability and durability for EFS. So EFS will be usable in US West in Oregon, US East, Northern Virginia, and EU in Ireland. The preview is scheduled for this summer. All the data within EFS is stored in multiple availability zones to provide high availability and durability. So any system object, a directory, a file, and a link is redundantly stored across multiple availability zones within a region. And this is automatically done without any configuration on your side. When you access data, we provide read after write consistency across different availability zones. So if you read in one availability zone, it's guaranteed that you have the latest data, even if the data has been written in another availability zone. So let's wrap up this presentation. With EFS, you also have simple and predictable pricings. With EFS, you only pay for the storage space you use. There are no minimum commitments or upfront fees. You don't need to provision storage in advance. You only pay for the storage space that is used by your files. And there are no other fees, charges, or billing dimensions. And EFS pricing is 30 cents of dollar per gigabyte per month. So what to do next? If you are interested, you can learn more on the EFS page in the Amazon website, so aws.amazon.com/EFS. There you can request an invite for our preview. And if you are in one of our events, you can stop by at our booths if you have other questions. Thank you.